Let's read the question together. Figure 2 shows a model of a giant lattice of metal. Looking at figure 2 here. Remember that metal bonding is often described as metal ions in a sea of delocalized electrons. We know that metal ions are much larger than electrons. So therefore, looking at this, we can see that the larger grey spheres must be the metal atoms or ions, and the smaller ones must be the electrons. Let's look at part A. Name the particles A and B. So name is the command word. That means say very simply what you know. So A is pointing to the small particles in the lattice structure. These must be electrons. We don't need to say that they're delocalized. That's not what the question's asking. It's just asking me to state simply what those particles are. Looking at B, these can be classified as metal atoms or metal ions, whichever you would prefer. Let's look at part B. Explain in terms of the giant structure shown why the material is a good conductor. So the command word is explain. And we're thinking about this particular structure here and why it is a good conductor. We do need to consider that being a good conductor can be being an electrical conductor or being a thermal heat conductor, and metals are both. So we need to make sure that our answer refers to both electrical conduction and thermal conduction. So, metals have delocalized electrons which allow them to be good thermal conductors. These electrons are free to move and carry charge. So metals are good electrical conductors. So that is explaining in terms of the structure that it's all about these delocalized electrons that allow it to conduct.